Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 10th, 2025, just 2 days ago. This paper tackles a huge limitation in current AI agents, their inability to adapt after being deployed, by proposing a new paradigm of self-evolving agents that can learn continuously. The paper is titled, A Comprehensive Survey of Self-Evolving AI Agents, a New Paradigm Bridging Foundation Models and Lifelong Agentic Systems. And it lays out a really fascinating roadmap for how AI might learn and grow on its own. It does this by introducing a unified framework for these systems, and even proposes 3 guiding laws for their safe and effective self-improvement. Also, the authors shared their work on GitHub. If you check it out, you'll find the main Evo Agent X project for building these self-evolving agent ecosystems. They've also put together an awesome list, which is a great collection of related papers and resources for anyone wanting to dive deeper. Alright, this next figure charts out the paradigm shift they're talking about. It shows a roadmap starting back with model offline pre-training, or MOP. That's where models were just trained once on static data. The path then progresses to model online adaptation, or MOA, where we could start fine-tuning them after deployment. From there, we get to multi-agent orchestration, or MAO, with multiple agents collaborating. Finally, the road leads to the key idea here, multi-agent self-evolving systems, which is the future vision of truly adaptive AI. This table then details those 4 paradigms we just discussed, comparing their feedback mechanisms and key techniques. You can see the progression clearly. For model offline pre-training, the interaction is simple, just a model learning from static data. Then, for model online adaptation, the model gets feedback through supervision, like labels or scores. This evolves to agents simply exchanging messages in multi-agent orchestration. And finally, to the most advanced stage of multi-agent self-evolving systems, where agents learn directly from signals in their environment. This next figure gives us a visual taxonomy, a kind of family tree, for these different self-evolving techniques. It's organized along a timeline from 2023 to 2025 and splits into 3 major directions. On the left, we see single agent optimization, focusing on improving things like an agent's prompts, memory, or tools. The middle branch covers multi-agent optimization, which looks at how groups of agents can coordinate better. And finally, the branch on the right is for domain-specific optimization, with agents tailored for fields like medicine or coding. To understand how those different techniques actually work, the authors propose this conceptual framework for the self-evolving process. It's an iterative loop with 4 key parts. It all starts with the system inputs, which define the task for the agent. Then, the agent system, which can be a single agent or a team of them, executes that task. This action takes place in an environment, which provides feedback on performance using what are called proxy metrics, basically, stand-in measurements like accuracy. Finally, an optimizer uses that feedback to update the agent, closing the loop. Ultimately, this framework paints a clear picture of the future, a fundamental shift from static AI to truly adaptive agents. The core idea is that these systems can continuously evolve by using environmental feedback to optimize their own internal components, from prompts to tools. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.